Assalamu alaikum warahmatullahi wabarakatuh. Today we have a new topic for Algebra 2. Today we're going to talk about hypothesis testing. What's the hypothesis? Hypothesis testing to generalize over the population. What does it mean? So it means that the statistical analysis you did, you can generalize it over the whole population, although you took a small sample. That's going to give us two types of hypothesis. Null hypothesis that's when I have equality, so I have equal sign. Once I have equal sign, so that's the null hypothesis, and it's a symbol H dot. Or alternative hypothesis when I don't have the equal sign. So no equality. And in that case, I said it's HA. So H null, so that's H null, that's H alternative. If you remember when we talk about the confidence interval, we have three types of certainty. I have 90% sure, 95% sure, 99% sure. What does it mean? I still have 10%. I'm not sure. I still have 5%. I'm not sure. Still have 1%. I'm not sure. So that's what we called alpha, which is the critical region. So in that area, in the 10 and 5 and 1%, I'm not sure about my statistical analysis, but I'm sure for 90, 95, 99. So that's the first thing we have to clarify, that the remaining percentages represent the critical regions. This critical region may be one side or two sides. What does it mean? Here, in one side, so the critical region is going to be either to the left or to the right. In that case, I said left tilde or right tilde. In that case, I have the sign more than or less than. Maybe more than or equal, less than or equal, but I have greater than or less than. And here, mu is going to be less than k, and here is mu is more than k. In the two sides, I have equal or non-equal. So I don't have greater than or less than, either getting the value or not getting the value. So in that case, when I have now non-equal sign, it's going to be two tilde, and the critical region is going to be on the both side. So that's 1 minus alpha, 1 minus alpha, 1 minus alpha. Here is alpha, here is alpha, and here is alpha over 2, alpha over 2. So the critical region is splitting over the two sides. So what is the aim? So I do something called Z statistics. So I do my calculation. That's calculated. If the calculated Z fall within the critical region, I reject null hypothesis. I reject null hypothesis. But if it's not in the critical region, I accept the null hypothesis. Okay, so if I'm going to do hypothesis test, I have to go through some steps. First, I have to state and identify the hypothesis, either H null or HA. Number two, determine the critical region. Number three, calculate Z from the formula mean minus mu S over radical N. Four, I'm going to see to reject or accept the null hypothesis according to its location, Do we have an example? Yes. So we're going to start with an example. So let's say the president of the students' council had heard complaints that the cafeteria lunch line moves too slowly. The dining service coordinator assures her that the average waiting time is 6 minutes, 6 minutes or less. So what does it mean? 6 minutes or less. So it may be less or equal to 6 minutes. So that's the null hypothesis. So the alternative mu is going to be more than 6. I have the bigger size, so mu is more than k. That means 2 tilde. I'm going to continue. That's from the first give. Using a sample for 65, so here is n is 65. They found that the mean x dash 6.3 with a standard deviation 1.1 minute, and he with significance 5%. So 5% means 0.05. That's the alpha region. I set it up everything. Now I know it's 2 tilde. It's 5%, so it's 2. Sorry, it's 2 tilde. What? It's not 2 tilde. Mu is more than its right tilde. Right tilde. So when I do the graph, the critical region all the way to the right here. So that's 5%. So that's 95%. Now I wanted to find, using the calculator, I write env norm. So here 95.95, enter. It's going to give you almost 1.6448. So now I get the z value for this given. And if it's split, so I have to get two values, okay? Now I have to calculate the z value. Z, the average was 6.3, and my mu was 6. Standard deviation 1.1 divided by square root for the number 65 is giving me 2.2. Now look here. Here the line stopped by 1.644. Now 2.2 is located here. 2.2 is located here. What does it mean? It comes in the critical region. So I have to reject the null hypothesis. I have to reject the null hypothesis. Okay, I'm going to do one tail to see how it's working. Now, I'm going to read the question. Giroud wants to determine if the advertisement show is accurate using a sample of 42 pizza. So is an n is 42 pizza. Giroud calculated the mean, so x dash is 99.8 pieces, and the standard deviation 0.8, and the alpha region is 5%, and the mu, he said, there are 100 pepperoni on every large pizza. So mu equal to 100 or mu doesn't equal to 100. So I have equal and not equal. So if it's equal, that's the null hypothesis. And if it's not equal, that's the alternative one. Since I don't have the equal sign, means I have two-tailed. So the alpha region is going to be divided by 2. I have 0.025, 0.025, and the 0.95% here. So I have to find two values. Invo norm for 0.025, and it's going to come by a negative 1.959, and invo norm for 0.975. Here I added these two to find the line here. So it's giving me the same exact value, 1.959. So I have one positive, one and negative. So I found the C. So the C is coming here, one at negative 1.96 and the other one is 1.96. I do the calculated one. So mean minus mu divided by standard deviation over square root for the n. The average is 99.8 and mu is 100 and standard deviation 1.8 and square root for 42, that's the number, giving me negative 1.62. So negative 1.62 comes before negative 1.96. So it's coming not in the critical region, it's coming in the normal region. And in that case, I accept the null hypothesis since it comes in the right region. Hope you understood, and I wish you a good day. Assalamu alaikum wa rahmatullahi wa barakatuh.